All right, today we are discussing sketching angles. So we are going to be drawing triangles in the coordinate plane. So you have to understand how to actually draw an angle in the coordinate plane. So this is the coordinate plane. It's got the x-axis and the y-axis. And when you take the the y-axis and the x-axis, and you draw them, you get four sections called quadrants. So quadrants are created by the x and y axis. Okay, axes, whatever. The origin, okay, is the center, the coordinates 0, 0, where the axes meet. The four quadrants. Quadrants are, I always think of the C. They're always in the C order, so meaning counterclockwise order. So if you draw a C here, you get quadrant 1, and then you'll hit quadrant 2, and then you go to 3, and then you go to 4. So it goes in counterclockwise way. So we always name with Roman numerals. If you use our actual number, it's not considered correct. It's like their actual name is Roman numerals. All right, so when we're sketching an angle in standard position, there's certain pieces that you need. So we're going to be talking about three types of angles. The first type of angle is when they're written in standard, drawn in standard position. So you have to know how this angle has been drawn, if it's a standard, if it's a reference, or coterminal. Okay, so the vertex is always at the origin. The initial side is always the positive x-axis, Okay, this is always the initial side. And then we measure going up if it's positive and down if it's negative. So the next side is called the terminal side. So terminal, where something ends, right? So that's where the angle ends. So this terminal side, you could have either gotten to this terminal side by going down or up. So if you go up, it's a positive direction, positive angle. And if you go down, it's considered a negative angle. Okay. So you may have to determine where the quadrant the angle terminates. So for example, this particular one, this angle ends in quadrant, that's interesting, ends in quadrant 2 here, because its terminating side is in quadrant 2. So what quadrant is the terminating side, is the ending side. Okay. Rotation about the origin. So when we draw, I just talked a little bit about that. But when you draw an angle, in standard position, you always understand that the x-axis is one side, so you don't have to worry about drawing that side. You only have to draw the ending side and which direction you went. Okay, so counterclockwise, so if you start at the x-axis and you go up, that's counterclockwise. So I like to say that's up from the x-axis. And this would be a positive direction. So it's like almost counterintuitive again, like, I don't know. So it's the positive direction, so this would be a positive angle. Clockwise would be starting here and going down. So let's change a color for down. So if you're going down, like if you're in the red, you're going down. Anyway, so when you're going down, this is considered clockwise. And this is a negative direction. The quadrantal angles are angles that hit on the axes. Terminating side is an axis. Okay. So when we do this, so say I went up and I drew an angle right here, you could literally measure that angle and figure out what the actual angle is. If I start here and I go up and I go to the x-axis, that is a right angle. So that angle at the y-axis is 90 degrees. So the first quadrantal angle is 90 degrees. And then we start here. If we went to here, that's 180 degrees. And then 270 and 360, of course. So 270 would take you to the negative y-axis, and 360 would be a full circle all the way around. Now, quadrantals could also be negative, so if I went in the negative direction, I went down here, and I hit there, that's the negative direction, so that would be negative 90. It is considered a quadrantal. And then negative 180, negative 270, and negative 360. Okay, now we could keep going, higher and lower for negatives. So, for example, let me just erase this a little so that we can do another one. Sorry. So if I were to draw an angle here, when you draw an angle in standard position, you have to draw the terminating side and you have to draw the little swoosh. The little swoosh is the angle that we start here. We start at the x-axis, and if it was positive, we go up and we swoosh around. Okay, that is an angle that's between 270 and 360. So let's say it's like 300. Okay, so you had to know it was positive. If you went the other way, this would be negative, and that would be a negative angle. We can swoosh around, and that's we're going to talk about coterminal in just a second. So when I say swoosh around, I mean you can go a full 360. So if I go up, I can go a full 360 and then another 300. So the swoosh has to show what the angle measure was if you went around and around. Okay. All right, what degrees are in each quadrant? So if you were to draw an angle in this quadrant, what would the degree be? We don't really know exactly because we don't use protractors here, but we do know that it would be somewhere between 0 degrees and 90 degrees. So quadrant 1, if we're talking positive, is always between 0 and 90. Quadrant 2, so if we're over here in quadrant 2, that was quadrant 1, we're here. Go in the positive direction, we're going to be between 90 and 180. Again, 90 and 180 are not included in this because those are the quadrantals. They're not in a quadrant. Okay, so this is 180 degrees. Then we go down here. If we're in quadrant 3 here, we're swooshing all the way over to here. That's somewhere between 180 and 270. And quadrant 4 is over here between 270 and 360. So if you went negative, then just flip everything around. Okay, so if we went in the negative direction, I'm not going to write it on over here. I'm going to write it over here. So if you went negative, this would be negative 90. So quadrant 4 would be between 0 and negative 90. Quadrant 3 would be between negative 90 and negative 180. And quadrant 2 would be negative 180 to negative 270. And negative 270 to negative 360. Okay, so the negatives matter. Okay, then, so we talked about those are standard angles, meaning their initial side is on the x-axis, the positive x-axis, and the terminating side, and the little swoosh tells you the measurement. Okay, if we talk coterminal angles are angles that end in the same spot. Okay, so let's just write that. coterminal angles end in the same spot. So if you do think about it, if this is an angle like 120 degrees right here, this is 120 degrees, if you draw an angle of negative 240 here, you will also have an angle that ends in the exact same spot. Okay, but, so we know that 120 and 240 are coterminal, or negative 240, excuse me, are coterminal, but we could find more. And the way that you find more is, basically, if you just started at this point and you made a full circle all the way around, 360 more degrees, it would also be coterminal. So there's, not to be dramatic or anything, but there's an infinite number. And all that you have to do is either add 360 to the number or subtract 360 from the angle. And that will tell you all the angles that are coterminal. So if I do 120 plus 360, that's 480. So 480 is coterminal. Add another 360, I get 840. If you were to draw all of these angles, they would all end right here. Okay? But you could also go backwards, so that negative 240 is coterminal to it. But if I subtract another 360, negative 600 would also be coterminal. I said 600 and wrote something else. So all the angles that are coterminal, so this is the second kind of angle, is coterminal angles. Excuse me. Add or subtract 360, and you'll find all the angles that are coterminal to a given angle. Okay? So if I want to know if these angles are coterminal to negative 37, all I have to do is take negative 37 and add 360 to it. If I add 360 to it, I get 323. That's not there. If I add another 360, I get 683. Nope. Okay, so it's not this one, no. Okay, I got up to, I went 323, 683, add another 360, I get 1043. Okay, that's not, so that one isn't. So these are the only numbers that are coterminal. I could also take negative 37 and subtract 360. I get negative 397. Nope. This seems like a pointless thing that I'm doing here. So negative 397. No. Subtract another 360. Negative 757. This one seems like it should be. Nope. Okay. This is terrible examples. I'm just throwing that out there for my own edification here. So the negative ones, negative 397 and negative 757 are it. So none of those angles are coterminal to 37. All right, and then finally we have our last kind of angle, which is our reference angle. So reference angle is different than your standard angle. Reference angles are formed by a terminating side, okay, and the closest x-axis. So reference angles are always positive, and they're always acute, meaning they're always less than 90 degrees. So just looking here, if this is an angle drawn in standard form, the reference angle would start here and go to the x-axis there. For this one, again, if this was a standard angle, you do have to have a standard angle, a terminating side already sitting there. You take the terminating side, which is the one that you can see, and you go to the closest x-axis. So that's that one right there. So this one, if I was in this quadrant, it would go up, And if I was in this quadrant, it would go up. So reference angles are always formed by the terminating side and the x-axis. Okay, and when we measure them, we don't care how they're drawn. They're always positive and always acute. So they have to, obviously they're acute, but they're always positive when we actually draw them. So if I were to draw negative 120 degrees, so negative 120 degrees, if I draw this in standard position, I would go down to negative 90, and I would go like 30 more. So this would be 120 degrees drawn in standard position. So when you draw an angle in standard position, you always have to include the little swoosh with an arrow and the terminating side with an arrow, okay, at the end. That is ugly. But then when we draw the reference angle and we decide what the reference angle is, if this was negative 120, this is the reference angle from this side to the x-axis. So what is the measure of this angle? So you really just have to get to the x-axis. There's many ways to do this, and I'll give you like little shortcuts, I guess, in class. But the easy way to think about it, if I wanted to get to negative 180, I would have to go another 60 degrees. So that's my reference angle, 60 degrees. Because this full angle right here, from here to here, is 180 degrees. So I've already taken up 120, and that's the kind of way to go about it. It's 180 minus 120, which would be 60. It's kind of like the shortcut or the hack or whatever. So 510, if I want to draw 510, so if you want to draw 510 in standard position, what you have to do is you need to figure out where this ended. So 510, if we drew this, it's bigger than 360. So we know we went around the circle one time at least. So I would find an angle that's coterminal to it. So I subtract 360 and I get 150. So 150 would end somewhere like here. So 510, that angle 510, if I were to draw this in standard form, would start on the x-axis on the positive side. It would go around 360 degrees and then another 150. Okay? So now to find that reference angle, you go from this side to this angle, and how much is left to finish that off? And right there, that's 30 degrees. So that's the reference angle. All right? A little long. Sorry about that, but it's been a blast. Have a good day. Bye.